This is Professor Belton. This is Trigonometry, Chapter 1, Section 5. This is Part 2 of the video. In each quadrant, the trigonometric function is either positive or negative. So nowhere it's positive, the mnemonic that's used is a smart trig class, where A stands for all trig functions in the first quadrant are positive. Smart, sine, its reciprocal, which is cosecant, of course, are positive. Trig, tangent, third quadrant, and its reciprocal, which is cotangent, is positive. In class, cosine and its reciprocal secant is positive in the fourth quadrant. Also, you can just use your pre-algebra skills to know that this is the positive quadrant, this is the negative positive quadrant, this is the negative quadrant, and this is the positive negative quadrant. Okay, and of course, whenever you do a coordinate, the coordinates are a cosine comma sine in the unit circle, right? Because it's x over r and y over r, so you need those x and y values in the coordinate to get the cosine and sine. So if I answer these questions here, determine the quadrant in which the angle lies. Angle theta lies, given the tangent is negative and the cosine is positive. Well, tangent is negative in the second quadrant, and it is negative in the fourth quadrant, because tangent of an angle is sine of an angle over cosine of an angle. Therefore, if one of them is negative, the outcome of tangent is negative. But I only can have cosine positive according to this. Okay, well, cosine positive is in this quadrant. So the answer is quadrant 4. Okay, so the next one, I want sine negative and cosine negative. So pause the video, think for yourself, and answer the question. Okay, so for both being negative, that is the third quadrant, because both cosine and sine are negative. Okay, so I know that information. We can place trig functions in their proper quadrant. So if we're going to have a tangent that's negative, that is either going to be in the second or in the fourth quadrant. So either I have a negative 2 over 3 or a 2 over negative 3 when I draw the triangle. So the question is where? Okay, well, I also know that cosine is positive. Therefore, it must be in this quadrant, because in this quadrant here, cosine is negative, because this is the positive negative quadrant. Okay, so I have a choice. I can either go 2, then 3, or I can go 3, then 2. So the question is, how do I know which way to go? It's going to be one or the other. Well, if I draw the angle in the corner here, there's one way to know. If I draw this angle, theta, okay, and I go, let's see, over 3 and down 2 when I make the triangle. Alright, that would be 3 here and negative 2 here. So what is tangent? Tangent is opposite over adjacent, so that would work. The other way, it would not work. So that's one way I know. The other way I know is if I look at the fraction, if I think about lines, that's rise over run. So in my picture, y is negative 2, that's rise, and 3 is the run going left and right. So that must be the appropriate way to go. So the answer must be with the negative on top to make this picture work. So to get the radius, I need to do Pythagorean theorem, because essentially this is a right triangle. So r squared equals 3 squared plus negative 2 squared. So r equals the square root of 9 plus 4. So r equals the square root of 13. Okay, so sine. Okay, so we have a coordinate right here, of course. Alright, let's do that coordinate. So our x value is 3 and our y value is negative 2. So y over r, x over r, gives us our sine and cosine. Either I can do sine over cosine to get tangent, or I can do y over r. If you do sine over cosine, it's simply negative 2 root 13 over 3 over root 13, which the root 13s would cancel, leaving you with the same answer. Alright, so if I reciprocate, get the other answers. The root 13, negative 2, root 13, 3, and 3, 2. Just put the negative on bottom, or top, rather. Okay, pause the video. Try the student problem for yourself. Okay, student problem. Tangent is negative, so that means it's this quadrant or this quadrant, because this is the positive negative quadrant, and this is the negative positive quadrant. So sine over cosine would make tangent negative, but cosine is negative, so cosine sine, it must be this quadrant right here, cannot be this one over here. So I have 1 over 3, so it's either negative 1/3 or 1 negative thirds, one way or the other. So I have to figure out which way to make the triangle in this quadrant. So I'm going to go over 3 and up 1 to make the triangle like this. So I have negative 3 and a positive 1. Well, how do I know that? Well, if I look at this, this is opposite over adjacent, which gives me a 1/3. Okay. Also, rise over run is a little quick way to remember how to figure out where it goes to. So the negative goes left, and the up is positive 1. So the r squared equals 1 squared plus negative 3 squared. So r equals the square root of 1 plus 9. So r equals the square root of 10. Okay. That is not a very good equal, so let's fix that. Okay, so r is root 10, so if I extended it all the way around, of course, for the circle, the radius would be root 10. Okay, so we have a coordinate at the corner of our triangle, which is negative 3 comma 1. That is our x and y. So y over r, x over r, y over x. And reciprocate. And likewise. Okay, so knowing where things are positive and negative is important for evaluating trig. Okay, let's go to the next page. Alright, so we want to break everything down to an acute angle. We do not want angles that are obtuse or greater. Okay, so we're going to make what's called a reference angle, which will help us get the same exact answers, but in a more efficient, quicker manner. So if you're in the first quadrant, notice the first quadrant's missing here. The reference angle is equal to whatever angle you're at. So the first quadrant is not shown here because that's irrelevant. You do not need to do reference angle for the first quadrant. All other quadrants have angles that are bigger than 90 degrees. Thus, you need to find a reference angle. A reference angle is denoted with a little exclamation, not exclamation, I'm sorry, that's the wrong symbol, single quote. Okay, so what you notice is when you make an angle takes two sides. You need the terminal side and the x-axis to make that angle. So in the next one, you need the terminal side and the x-axis to make the angle. And in the last example, the terminal side and the x-axis make the reference angle, which is an angle that's less than 90 degrees. So, and it's always a positive angle. Okay, that's the key. It's a positive angle, and it's acute, right? So less than 90. Okay. So make sure you use the closest x-axis, obviously, not the deciding on positive versus negative. Okay, so let's find reference angles for the next questions. Okay, let's say I have 345 degrees. That's almost all the way around, but I don't want to figure out my sine, cosine, tangents for 345. I want to figure out the rest. So if I do 360 minus 345, I get 15 degrees. So 15 degrees is my reference angle. Okay, if I do 5 pi over 6, that's almost, this is 0 pi over here, this is 1 pi over here, right? So I almost made it around to 1 pi. So if I did 5/6, the remainder is 1/6 left over for my reference angle. So if I have negative 135, I almost made it halfway around because this is 0 degrees, this is negative 180, right? Because pi is 180. So I almost made it 180 degrees, so the 180 minus 135, doesn't that make it 45 degrees? Okay, but the reference angle can only be a positive answer. Okay, reference angles are always positive. So go over to here, it's very similar. If it's not labeled, it must be radians. This is 0 radians. This is pi radians. So you do not want to round, you do not want to round, you do not want to round, because rounding would send the side lengths in your trig problem way off when you do the rounding of the angle. You don't want to do that. So what you want to do here is pi minus 2.5. Okay, because the whole angle is pi, minus the 2.5 that was already used will give you the remaining, so do not round. Okay, pause the video, try the student problem for yourself, or student problems. Okay, so if you have 210 degrees, that's a little more than 180, correct? So I have an angle down here, so I went 180 degrees from here to here, right? And then I went to 210, which is another reference angle of 30 degrees. So our answer for reference angle is 30 degrees. Okay? Alright, 7 pi over 4. Well, if I go 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, I'm all the way over to here, because I went from 0 to pi over 2 to pi to 3 pi over 2 to 2 pi. So I almost made it to 2 pi, because 8 pi over 4 would be 2 pi, right? So if this is 7 pi over 4, then the remaining angle is pi over 4, which would give me 8/4, which is 2 pi. So my reference angle is pi over 4. Okay, next one, negative 240. So if I go negative, that's 90, 180. Well, that's 270 on the next one, so I didn't quite make it to 270. Alright, so from here to here, that's 180 degrees, but I have to go 240. So, well, I'm actually going negative 180, aren't I? Right? So that'd be another 60 degrees to get to the 240. Okay, so that is my reference angle. So my reference angle is 60 degrees, which is, reference angles are only positive. Okay, 3.6, I have to think. It's not labeled, therefore it must be radians. So I have 0 radians, pi over 2 radians, 1 pi radians, and 3 pi over 2 radians. So I go from 0 radians, which is 0, pi, which is 3.14, and 3 pi over 2, which is about 5 point something, I believe. I'm not too sure on that. You can type that in. It's 1.5 times 3. So I'm thinking about 5 point something-ish, somewhere in there. So 3.6 is clearly in here, isn't it? So that means I went more than pi, but less than 1.5 pi. So I'm somewhere about right there. Okay. So I went 3.6, and if I subtract the pi, okay, that'll give me what's left over, because I went more than pi. So my reference angle is 3.6 minus pi. Okay. Alright, so let's try the same thing now, but now we're going to do ones that are more than 360 degrees. Okay, so let's say I have 580 degrees. So 580 degrees minus 360 degrees gives me 220 degrees. So that means I went around once and then 220 degrees more. So starting at the positive x-axis, I went around once, and then I went around another 220 degrees. Okay? So the question is, what is left? So here we're going to use alpha, because you can use alpha, beta, or theta, or any Greek letter for the angles. So I made it to 180 degrees over here, right? Because this is 0. This is 180. So 220 minus 180 gives me a 40 degree reference angle. So my reference angle is 40 degrees. So instead of doing 580, I should do 40 degrees for my trig functions. Okay, 8 pi over 3. Well, 2 pi, in this case in thirds, is 6 pi over 3. So if I do 8 pi over 3 minus 6 pi over 3, I get 2 pi over 3, which means I went around the circle once, and then 2/3 more. So I went around the circle once, and then 2/3 more. Okay? So the question is what's left. Well, if this is 0 pi, and this is 1 pi, and I went 2/3 pi, isn't there 1/3 left over? So my reference angle is a third of pi. Okay, we'll do a negative one now. So it's in sixths, right, in radians. So 2 pi in terms of sixths is 12 pi over 6. That is 2 pi. So if I take negative 13 pi over 6 and add 12 pi over 6, I'm going to get negative pi over 6. Okay, which means I went around the circle once, plus another sixth. But I'm going negative. Okay, So if I go negative, I'm going around the circle once, right, all the way around, plus another sixth after that. So I went around all the way once, and then another sixth. So that sixth is also our reference angle, okay? So our reference angle is pi over 6, okay? All right, pause the video, try the student problems for yourself. All right, 665 degrees. So if I do 665 degrees minus 360, that's 305 degrees, which means I went around once. Let's get another color here. I'll go for a red. Then I went another 305 degrees. So another 305 degrees to right there. Okay, so that's 305 degrees for just the red part. The blue is a 360 that we went around for a total of 665. Okay, let's go. All right, so the question is what is left. So if I went 305, and that means the remaining degree is 60 degrees for our reference angle. Okay, because no, that's not right. 55 degrees. I can't do math. I was thinking 300 there for a second. So 55 degrees and 305 gives me my 360. Okay, next one. We'll go back to blue here. So I have 15 pi over 4. So 2 pi in this case is 8 pi over 4, right? That's 2 pi around. So 15 pi over 4 minus 8 pi over 4. So that's what? 2 more is 10s and 5. So that's 7 pi over 4. So I went around once. Went around once. Then I went around another 7/4. So I went around another 7/4, which is almost all the way around, right? 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. So what's left over is another fourth. So my reference angle is another fourth left over. Okay? Because if you add that to 7/4, you'll get 8/4 because we almost run around another time. Okay, so we have 11 pi over 3 in the last one. So in this case, 2 pi is 6 pi over 3. Okay, so we have a negative 11 pi over 3 plus 6 pi over 3 is negative 5 pi over 3. So that means I went around once plus another 5/3. Okay, so I'm going negative, right? So I'm going negative. So I went around once negative. Okay, let's change colors. Then another 5 pi over 3. So that's almost all the way around, right? So almost all the way around, because another pi would be 6 pi over 3. I'm sorry, another third would be 6 pi over 3. So the remainder is a pi over 3, because the reference angle must be positive. Okay? All right, that is the end of part 2.